Hello everyone, welcome back to my channel, and today we are going to look at a project focusing on time series dataset. And for this specific project I'm going to use data from this website. Has got numerous datasets, our world in data, and our special focus will be on analyzing the time series dataset of continents by electricity generation. So I used the resources option to download the dataset, and then went to charts and explorers, and then just clicked on energy. And after sorting out the energy dataset, I kind of did some pre-processing so that I do not focus so much or don't consume so much time on the video. And once I did that, the dataset that I had is saved as an electricity CSV file, and I've attached the link to the dataset at the bottom of this video. So you should be able to access the dataset that we are going to use in this project. So a brief description of the dataset. It has got around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 10 columns. We are not going to use all the columns, but the key important columns are the continents. We have got the year, and then we have got different electricity types, whether it's generated from biofuel, coal, fossils, gas, hydro, renewable energy. This is in comparison with the GDP, with the population energy per an individual in a whole year. And then we have got the last part, the resultant carbon emissions based on the kilowatts of power used by each consumer. So this is the data set. And one thing, doing basic research on this, I realized that the best approach to use or to display datasets or time series datasets is to have kind of dashboards. I'm not very competent in dashboards, but we are going to learn that along the way, and we are going to follow this by 2V Data Analytics. It's a very, very good tutorial on this. So this is what this video is based on. So you can feel free to check on her YouTube channel on this. But we are going to use this for the rest part of the video to give insights onto that data set. So to get us started, the first thing that I need you to do is to, if you are using Windows, go to command prompt. If you are using Mac or any Linux based system, go to terminal. So ideally, you should have got something like this. So let me just restart my terminal. So this is where it all begins. So we are going to analyze that data, or format that data into a way that makes sense to users, and then use a dashboard. So for those of you who don't know dashboards, what they are, this is simply a simple way of displaying data sets in a web-based format, so that users can interactively query or even visualize the data set. And I think that's a very, very important tool, especially if you're working in the corporate world, or you want to display the output of your work in a more interactive way rather than using just static charts. So the first thing that you need to do is open the terminal. And once you open the terminal, by default, your terminal should be on the base environment. So that is where all your installations, whether it's all your Python installations are. So on Windows, again, it's command prompt. In Linux or MacBook is a terminal. So the first step that we need to do is to create and move to the folder where we are working on. So in my case, I'm working on a folder inside my documents folder, and it's called the technical, and that's where I'm gonna work on. So quickly, you can navigate towards that folder in your terminal. So I can just do cd, or first of all, just list the directories that are in your computer. If you don't know how to do this, check for my previous videos. I explained how to do this. So ls will allow you to list, and then I'm interested in the documents folder. So I'm going to do cd documents, can autocomplete by pressing tab, and then do ls to see the folders. then I'm interested in this folder here. So I'm gonna do cd jar technical, and they can auto-complete it by pressing tab. And this is where we have got this different folder. This is where my data set have been stored, and then these are the different directories. So I'm gonna create a new directory here by using the command mkdir, which is basically make directory. And the name I'm gonna give it is gonna be electricity. And then, so now I have got this folder created here called electricity. Now I wanna get inside that folder, and to do that is very simple. Just do cd to mean change directory, and then type electricity, and you can press tab to autocomplete. And then I'm now inside my folder. If I do ls, you can see there's nothing inside because it's an empty folder. Of course, let me clear everything so that I've got a clean terminal. Now the next thing that we're gonna do, let me just make this bigger so that those who are using smaller screen can see what I'm working on. So the next thing now is to install all the packages that I want to use. And to do that, before installing that, I want us to create a different environment. So environments in Python is basically allowing you to work independently of it allows you to work independently of the other environment where you installed previous packages. So you want to install new packages in an environment where we don't have got other packages that might lead to conflict. So to do that, we have to create something called environment. And to create environment in Python, it's very simple. The first thing we're gonna do is to simply use this command here. So if you want to create environment, so just type Python to mean you're creating environment in Python. And of course, we are using Python 3, and then -m, and then it's a virtual environment. So it's like you're working within a virtual environment. And once I do that, so sorry, I need to add arguments to that. So creating is Python 3, and of course it's that, and then it's virtual environment, and I want to create it inside the folder where I'm working on. And that folder that I'm working on, as you can tell, is the folder called electricity. So what I will do is just do Python m virtual environment, and then I can easily VNV. Okay, so I'll do VNV, and then have this dot / to mean that I'm creating the environment inside that folder, and wait for it. It's gonna take some time depending on your speed. So now the environment is created, so I can clear. And then the next thing is to activate that environment so that I'm within that environment. I'm moving away from my dominant environment that comes by default, which is normally the base environment here. So I'm going to move to the new environment that we have created inside the directory called electricity. So to do that, to activate it, I'll just use source bin / activate, and this will activate the environment. You can see now it has changed from base to electricity. So it means now I'm within that environment. So this environment is completely new. It doesn't have got any installations. So the first thing we need to install the libraries that we're gonna need to use in this work. So the first library that is very, very important is the hvplot. And hvplot allows us to make interactive data frames and plots within our Jupyter notebooks. So to install that, we use the pip3 install. You can feel free to use Anaconda, but I find this one to be working. hvplot, and also I want us to install a Jupyter Lab. So Jupyter Lab is kind of very similar to Jupyter Notebooks, but it allows you to be more interactive with web pages. So I'm going to do Jupyter Lab. So now I have got 3 installation: HVplot for creating interactive data frames, and then Jupyter Lab to allow me to run my notebooks in a web-based environment. So press enter, give it time. It's going to take some time to run. So it's still running. So this step has to be exactly like this for our interactive database to work. So that is something that I realized from watching the video, and it's a very interesting way to build interactive data sets. So now that I've installed HVplot and Jupyter Lab, the next thing that we need to install is a Python package called panel. And panel have to be installed in the base environment, not in the electricity environment, because if you install it within this environment, it's not going to work. It's going to start having issues. So that is something that I learned the hard way. It wasn't working until I went back and read about it, and then realized that I was making a mistake on that. So to do that, I will have to deactivate this environment by just doing conda deactivate. Activate conda base. So now, given that I'm on this base environment, I can do pip3. This is how we install the panel. Install panel. Give it time. So I've already installed it before this video, so that's why it runs faster. And then now I have to move from the base back to my initial environment. So how do I do that? I just do conda activate electricity. I'll just do source bin activate. Now I'm in my electricity, back to my electricity environment. So now that I'm in this environment that we want to work on, the next thing is now to launch Jupyter Lab so that we can start analyzing the data. So let's do Jupyter Lab. Just type it like that. It should be able to launch so that we can start working on it right away. So give it time. It's going to open up on your browser. So here it is. It has opened on my browser. Now, if you look at the folder, this is the folder that you have. So we are inside the folder called electricity. These are everything that is inside electricity. There's an image I provided, so we're gonna use it at some point. So if that is the case, then move to the folder where you are working on. So as I told you, I'm working on geotechnical, and this is where it is, the electricity. So basically, whatever you are seeing on your browser is this folder here. So you can see the bin folder, the etc, include libraries, and everything else. So there's some image that I will want you to download. I've shared the image called energy on the link down below. So please make sure that you copy that image, which is .png, and store it here outside these folders or inside this folder. We will use it later on. So now that we have the Jupyter Lab, the next thing is to start creating our or analyzing our data set, and that is very straightforward. So click on the kernel, and the first thing is let's rename this folder so that it has got a name. It's not just called entitled. So we can say electricity just to in short form. And the first thing we do is to import the necessary libraries that we're gonna use. So we're gonna use OS. We're gonna use import pandas for our data frame, SPN, speedy, import numpy, probably just in case it's np. And then this is a very different one. Of course, I want to have suppress all the warnings, so I'm gonna do import warnings to, and then have the panel is very important because this is what will allow us to create an interactive web-based server, SPN, and then we're gonna have pn.extension. So this allows us to make interactive tables, tabulator. Don't know if I'm writing it correctly. Should be able to work though. And then import hvplot. hvplot is what will allow us to connect the plots to the interactive widgets that we are going to create. So with that done, let's run it and see if it runs. Okay, wrong spelling, sorry, numpy. Should be panel, not panels. Hope that runs, yes. So the first thing is to read our data set, which is very straightforward. You are now used to this. So read the data set. I'll just have this one here. So let me define the data path. We use the OS library and then use the method .join. And since this is where we are, this is where our code is here, but the data set is here in the data side, so I will have to move one step back. So to do that is very straightforward. I can just do like this, 2 dots to mean that I'm moving one step behind the folder, this folder called electricity, and get inside the folder called data. That's where my data set is. And now define elect CSV, which is my data set. So I'm gonna do os.path.join. So I'm gonna join the name of the CSV to this path that I've already defined here, then comma, then check the name of my data set. So the name of my data set is electricity, so just copy it so that I'm sure that I'm writing the right thing. Okay, so that's what I have. Now let me define read it as a data frame. So I'm gonna use the pandas library and use the function read CSV to read that. And what goes inside is simply the name of the data path plus the folder. And then of course just display the first few lines. So I'll do df.head, maybe 3, that will be fine. Good, so our data set has been read. Sorry. Continent, year, biofuel, electricity. So this is the types of electricity generated, and this is the energy per person in a year. And then we have got the resultant emissions per energy consumption. So these are our data set. So as I said, time series data sets are very interesting because they are multidimensional. In other words, they are changing in terms of the quantity and the time. So if you look at just Asia, we have got different values for different categories of fuel and for different years. So this makes it very hard to visualize it using just one-dimensional plots. And that's why it's very important to use dashboards. And that's why I thought it was very important to take this approach in analyzing this data set. So now the next thing is to create our data set to be interactive. And for us to do that, we are going to make our data frame to be interactive using a function called interactive. And to make that interactive data frame, I will call it IDF to mean interactive data frame. We're going to use our existing data frame that we have already read here and then apply the interactive function that will make this data set interactive. So I'll do interactive autocomplete using tab. Seems like it doesn't understand. Once I do that and run it, should be able to work. So let me see. Yeah, this is what I have. You can see the data frame is kind of interactive. So that is the first step. The next step now is to define the widgets. So widgets are very interesting when you are looking at dashboards because they allow you to do controls. Some of the widgets that you are known to is things like drop-down menus. If you click on something, it gives you options and then you can select from that. Another one is sliders. You can use it to slide like different time frames or different intervals. And then we have got things like radio buttons, kind of clicks that you press and it gives you options. So the first one I want us to make is the year slider. So to make the year slider, we are going to use the panel interactive. So this is why we had to import this library because it has got a series of widgets that allow us to make our dashboard or make our data frame interactive. So I'm going to use pn.widgets. And I'm going to use integer slider. It means the values have to be integer because the years we cannot have got 20,050 or 2000.5 years. So I'm going to use integer slider. And the first thing, it has got different options. So the first thing that goes inside here is the name of the slider. So it's a string. So I can just say electricity or generation year. So the year that electricity is generated for that continent. So generation year. So it can be 2000, 2001. In other words, how many amount of biofuel electricity was generated in 2000. So this is the name of the slider. It doesn't matter. You can give it any name that is sensible. And then the first thing you do is to write the start. So start represents the minimum value of the slider. So in this case, I'm going to set it to 2000 because that is where my time series data set starts from. So it starts from the year 2000. And then the next one is end. So end represents the maximum value of the slider, which here I'm going to set it to 2022, which is the last data set that we have for the electricity generation. And then the step is simply the size of each movement on the slider. So I'll set it to 1, meaning the slider will move in increments of 1 year. So do that to 1. And then the last thing I'm going to do is value. So value, I'm going to set it to 2005. And this one, you can set it to anything. It's simply the initial value of the slider when it's first displayed. So I'm going to set it to 2000 so that at 2005, or let me set it to 2010, which is 2011, which is kind of the halfway. And then to see if that works, let me just click on it and show you the output of what you're trying, the widget, to see if you have created that widget. So it tells me PN installer generation takes 1 positional arguments, but 2 were given. So let me see. Yeah. So I have to specify this as name. I just wrote the string without specifying the argument. So here we have, so you can see our slider is called generation year. So the year that the electricity was generated, and it starts from 2000, but the value is 2011. In other words, it starts at the first display is 2011. So you can slide it all the way to 2000, which is the minimum or the start, or slide it all the way forward to the maximum, which is 2022. So this is what we are going to use, so that whenever we are displaying the data set, we can whenever we press the slide, it changes by year and it all changes by values. Interesting, right? Let me just display the columns so that in case I want to use them, I just copy them instead of typing them. So the next thing is I'm going to decide on how my dashboard is going to look like. So the display of my dashboard is going to be rectangular, just the general outlay of a web page. So I'm going to have four plots. So you can think of something like a cross here. So in the first quadrant on this upper left of the page, I'm going to have the electricity generated by basically hydropower, which is from water, and then the ones generated by other renewable systems. And I'm going to compare them by continents over a time period from 2000 to 2022. So that is going to be the first detail here. And then on the right, I'm going to have the same details, but in a tabular form, so that it gives you more information on what is happening here. So that is sorted for the top two plots. And then in the bottom left, I'm going to have, I don't know what I should have there. Let me think. In the bottom left, I'm going to compare the energy per capita for each continent. In other words, what is the total amount of energy that is equivalent to that consumed or generated for an individual in each continent here. So this one is just going to be the energy per capita over the years from 2000 to 2022 for different continents. And then the last part here, I'm going to have a comparative bar graph for each of the continents for different years for 3 different energy sources. So my choice of energy sources will be, it's going to be fossil fuel. I'm going to compare it with coal fuel and then biofuel electricity. So I'm going to have a chart here that compares the electricity generation per continent, but for different options for the years 2000 to 2022. So it's going to be 4 plots. And then on this other side, I'm going to have just extra information to make the dashboard look nice, just to make it more appealing and attractive. And that's why I told you I'm going to provide an image, or if you look at the link, there's an image I've already provided that you're supposed to add here so that we can make it as interactive as possible. Good. So that defined, let's create the first plot. So the first plot is simply a line plot of the hydroelectricity generation and other renewable energy generation for different continents from 2000 to 2022. So the first step to doing that is to create the axis widget. So let me just say y axis electricity. So this is for my first plot, which is going to be on the top left. And we use the panel library and use the widget method. And here we're going to use the radio button so that we can change the options from different electricity generation types. So I'm going to use radio button and then group, so that since there are 2, and the name. So the name is basically the axis, which is interesting. So let me have the name. So this is a string. So let me just say name. And then this is a string that sets the label of the radio button group widget. In this case, I'm going to just label it y-axis. So let me do that with a string. So y axis. And then the next thing is options. So I'm gonna have two options. You can select them from the reference. You can select what you want, but in my case, I'm going to use hydroelectricity, which is generated from water, and then other electricity or renewable, so that I can compare the two. So let me just copy it from here to be sure that I'm copying the right thing. Okay. And then renewable. And then there's a third option here, the button type. So this is the type, how you want the button to appear. I'm gonna select success. There are different options for this. I'm gonna select success, which by default makes it appear green. But there are different options. For example, there's default, there's primary, there's info, there's warning, there's danger. So it depends with what button you want. So let me just have the success button. And then I want to see if this has been correctly displayed or generated. So let's see how our radio button looks like. So you can see this is what I was talking about. So if you click on it, you can click on this one. So it's kind of like a radio button. Good. So now the next thing is to define, or first of all, select the continents, because this data set has got different continents. Like New Zealand is included, Australia, Oceania, but I want to exclude some like New Zealand and Oceania, because those countries are, like in terms of continent scale, they are too small for this comparison. So I'll just stick to the major continents. That's Africa, Asia, North America, South America, Europe, and maybe Australia. So let me create a list of that continents that I will use to check or iterate over my data frame. So continents. And to save time, I pre-made the list. So I'm gonna just copy paste. Feel free to type them, but I'm gonna copy paste so that this video doesn't take so much longer time. So Africa, Asia, Australia, Europe, North America, and South America. So that's the list. Now, the next step is to connect this radio button to my data set. And the first thing I want to do is use kind of take this data frame and group that, select the two columns, that is hydroelectricity and other renewable electricity. Only select those two columns and then group them by continents and by year and find an average for each year. So that is what I'm going to do in this line here. So let me just call it electricity. So I'm just combining the data set with the radio button so that it can be interactive and they are fused together. So I'm gonna use that. And then remember to take the interactive, what do we call it? The interactive panel. So the interactive data frame. So let me just write here, combine widget with interactive data frame. Make this markdown. I think that should be fine. Okay. So my interactive data frame is IDF, which is here already. Then, so I'm gonna select the year. I wanna group them by year and make sure that this year, anything that is greater than is less than or equal to year whenever moving the slide. So I'm gonna call this year slider here. And then I'm also interested in the continents. So I'm gonna check for if the continent is available in the continent list. So I'm gonna do IDF. The column name is, here is continent. Good. That is. So I'm gonna check if it's in this list that I've just created. Okay. So check on that. Of course, I have that. And before that, I think I need a square bracket over there. And once I do that, I need to group this by year and group them by continent too. So I'm going to do group by continent, which is a string, and then group by year. Okay. And then append in, I have to add the y-axis, okay? So this step, whatever I'm doing here is just filtering the data set, that make sure that I'm only selecting the data set which the year is less than or equal to whatever I'm moving on the slider here. And then the continent that I'm selecting is those continents that I'm interested in. I don't want to display all the continents. So this first part here is just filtering. And then this next part is to calculate, I'm going to calculate the mean for that year based on the y-axis column for each group. And then the y-axis electricity, this button here, variable, will be a string representing the column name to aggregate. So let me just copy this here. And then this is what I'm using to aggregate the data set. So I can simply do dot mean. I just want to find the mean, or if you want to find the total, that's fine, but it's the mean. And then convert this to frame, because once you aggregate the data set, it converts it to series, but you want to still maintain it as a data frame. So I'm going to convert it to frame, and then reset it to make sure that any missing index are removed. So I'm going to do reset index. And then I'm going to sort the values in descending order, beginning with the list here, which is 2000. So descend values, but I want to descend them by year. So by year. And then again, reset index. Drop any missing values. And that should be, once I do that, let me display it to make sure that it has done exactly that. So run this. This should not be here. Good. So this is what I'm having. You can see. So I can select hydroelectricity. It displays hydroelectricity. Other renewable energy, it displays other renewable energy. And of course, you can slide this over time, starting with 2001 to 2000. So these were the values in 2000, 2001. So I've included 2000, 2001 like that. So that's the whole purpose of this button here. So now the next step is to plot these values and make them interactable. So I'm gonna do a line plot. So I'm gonna do ECT plot equal to. So I'm gonna take this pipeline here. This is what I'm gonna plot, and use a function of hvplot that we defined here. So I'm gonna do pipeline dot hvplot dot line, since it's a line graph, and then the x-axis is gonna be the year, and then the variable name will be, I'll change them by continents, and the y-axis should be the Y electricity. So whether it can be hydroelectricity, it can be other renewable energy, it doesn't matter, depends on how many or what information you want to show. So Y will be that, Y equal to that. Let me just move them close here. And then line width, you can define what you want. I'll use 2. And then color map, I'm gonna select just set 3. Yeah, and then the title, equal to, I'll have something like electricity generation by continent, and then do ECT plot. So this is going to generate a line plot that compares the electricity generation for different continents by different years. So let's run it and see what we have. So I missed a comma here. Let me see the error. Continent instead of continent. Run that. Here we go. So you can move that. You can see, you can move that. Let me use the hydroelectricity. Yeah, so as you slide it over, it keeps on changing depending on the year. So this is what is going to be the first plot that we're going to generate. And then I want us to generate the next one, which is essentially the one on energy. So let me do that. Label that to energy per capita. The step is pretty much the same. The first thing that we're going to do is to define the button, and I'm going to use a radio button here. So I'm going to say define the y-axis. So let me call it that, energy consumption per individual, and then use the panel, use the widget method, and inside it use the radio button group to specify. So the name, as usual, you're gonna have y-axis, options. I'm gonna select the energy per capita here. Good. So that's what's going to be on the y-axis. Then our button type is going to be success. You can change this to one of those options that you want. Maybe for this one, let me try changing it to something like primary and see the options or how it looks like. Then run it. Having an error with that energy. Name options. Oh, this one should be as a list. So run it again. Yeah, so you can see it's blue if it's primary. Let me see default. What does it give us? Oh, default, it doesn't look nice. Info. Info, I think it requires more options. Warning, though this should not be warning. That's a bad way to do it. It's green, so let's use warning. Danger should be red if I'm not wrong. I'm guessing. Yeah, of course it's red. Okay, so let's stick to warning. Now use the pipeline, same style. So I'm gonna do the same thing here. To avoid repetition, let me just copy this the one that I did here and paste it here so that we save on our time. So I'm gonna call it kilowatt hour pipeline, and instead of having this, I'm gonna change only this. The rest of the stuff pretty remains the same, and of course I can display that here. Run it. So here we go. Next thing, now we have this. The next thing is to plot it. So I'm gonna do kilowatt hour hplot. Everything else remained the same, so I'm just gonna copy the one that we plotted here and change the variable names. So the first variable name that we need to change, instead of electricity pipeline, we're gonna take this, our kilowatt hour pipeline, replace it here, and then instead of y electricity axis, we use the one that we previously made here. And then the title is different. You can say energy per energy generation per capital. Then call it to see if it has plotted correctly. Good. So here we go. Can change. Can move the slider. Can see it's changing. The thing is, when I'm moving it, it's also changing the tables at the top, so it kind of makes it hard to see it interactively, but this is going to become clear when we deploy it on the dashboard. Interesting, right? So this will take, so as we said, the first plot is going to take the top left, this one is going to be bottom left, and then we need a table on the top right. So let me make the table for the two electricity consumption values. So I'm going to have a table for this here, hydro and other renewable. So let me make that straight, simple. So to make the table, I'll just say electricity, just to be consistent. Let me see what I used here. Oh, I used electricity, yeah. So I'm gonna copy electricity. Electricity table. Then use electricity pipeline. And then do pipe to make it an interactive table using a tabulator, which makes the table to be interactive so that when you move it, it can change as you'd select different options. Tabulator. Pagination. So I make the pagination remote. And then page size, I'll stick to something like 10. Page size, I'm gonna make it 10. Let me move this. Sizing mode. So the next option here is sizing mode. So how you gonna size your table? I'm gonna do stretch. There are different options, but I'm gonna select stretch width. This should work, so let me run it. Electricity pipeline, pipe, widgets.tabulator, pagination, remote, page size, sizing mode, stretch width. Run it. Pagination, the spelling, I think I've written a wrong spelling. So please correct that. Pagination. Pagination. So let me just click so let's see. So here we are. So this is our interactive table. You can see it's interactive. So just to explain this, the pn.widgets.tabulator, this provides a widget by the panel. So this is a panel, a widget, and it wraps the table into kind of JavaScript format and makes the table flexible. And then we have got the pagination remote. It allows remote pagination. Instead of loading all the data at once, the table loads data page by page, which is useful for handling large data sets, especially if you're dealing with time series data set, as is the case of this our data. And then this one, page size 10, it says the number of rows per page to 10. So users can navigate through pages to view the entire data set. And then the sizing mode makes the table stretch to fit the width of its container. So there are different other options for the sizing mode. You can select, I've selected stretch width, but there are some like fixed, stretch both, stretch height. It depends with your preference. So now that I've done with that, so maybe I should write here at the top. Interactive data frame, interactive table. So this allows you to navigate through the data set, make it markdown, run it. Good. Now the next thing I need to do is to create a radio button, or to create the last one to create a bar plot that compares the energy generation of all the continents by different energy types. So just to illustrate here, we have got this table before I go on. So this is the first page. You can see it's setting the page size to 10. If we change this to something like 20, then you can see it's setting them to 20 values. But for the purpose of this, let's just make it 10. And then you can select to the next page, next. So depending on the size of the data set, okay? So the next thing is now to create a bar plot that compares the energy generation for fossil electricity, coal electricity, biofuel against the continents for the years 2000 to 2022. So it's a 3-dimensional table, and that's why I told you dashboards are very important when you're dealing with multivariable or multivariable time series data set. So let me write that, create a I don't know if that's the right word, multivariable bar plot. Then let me just give description. No, markdown. Display the data set based on the electricity generation type. Here we display, we compare the data set based on the electricity generation type for between the year 2000 to 2022 for the continents. Good. So as usual, the first thing that we're gonna do is to create a radio button for our options. So the first thing I'm gonna do is to do y-axis, create that button. So I'm gonna call it electricity source, and then use pn.widget, and then of course I'm using the radio. Let me just copy this, don't want to type it. Okay, so I've copied that. The name of the axis, simple name, equal to y axis, then options equal to fossil fuel. So the columns I'm selecting for this, I'm gonna select, I wanna compare or wanna have a visualization of fossil fuel, coal electricity, and biofuel. So let me just copy them here, straightforward. And then, of course, I'm gonna use button type. Don't know if I should use success or, let me see other button type options, default or primary. Let me see primary. Then display this, see my results. Okay, so that's the primary. Here I used, which one did I use here? it was a warning, and then this was success. So let me use the primary. Good. Now let me select the continents that I'm interested in. So continents, world. So I'm interested in, again, I'm just copy. I don't want to type it anymore for the purpose of time. These ones, yes. Now I have to create or link this button to the dataset itself and then generate the plot. So very simple. As I did previously, I'm just gonna copy. Here is a good example. Create the pipeline. So straightforward, just copy everything. Give it a different name. Electricity bar pipeline. Of course, I'll have to display it at the end. Then inside of here, I'm gonna have Y axis. I think this should work. Yes. So you can see we have got biofuel, this one, coal, this, fossil, this. So I've selected all those. Of course, you can add as many as you want. Maybe I should just add to be as detailed as possible. So I've added biofuel, coal, fossil. Why don't I add gas? Let me add gas, electricity. Gas, electricity. Good. So I've added all those options. Biofuel, coal, fossil, gas. Yes. So now I have biofuel, coal, fossil, gas. Good. And then the next step is now to generate the bar plot for them. So what I will do, link pipeline to dataset, generate the time series comparative bar plot. So it compares the fuel generation for each of the continents over the time period, which is something cool. That's why you need dashboards for time series datasets. Good. So what I'll need to do now is to just copy the previous link, very straightforward. I don't want to type it again. Here, I think this is the plot. Can use this one as a template. So I'll call it electricity source bar plot. Electricity source bar plot. Of course, I'll need to display it at the end. And the pipeline is this one that I've already made here, electricity bar pipeline. Here. And then the axis is electricity y-axis source. Yeah. Good. And then I can say time series electricity electricity generation comparative plot. Continent, of course it's a plot, so let me use continental comparison. Comparison. They make this in the second line. Run it. Yeah. So this makes case, you can see the biggest case is Asia leading, followed by North America, really not North America, Europe, North America, Africa, South America, and of course Australia, smaller because of the size, I believe so. Can make this as interactive as possible. One thing that comes out clearly is, oh, I don't want this to happen. So it's not gonna stop. This is the problem with this widget, so I'll have to restart. I'll have to restart everything because it's not gonna stop. Oh, let me go to run. Can interrupt. Let me see if I can stop it from running. So let me just shut it. But now, when I'm rerunning it, I'll have to restart my terminal because I've been through this before. If you don't experience it, it's okay. So let me rerun my code again. So I've restarted it so that it doesn't continuously run as it was the case before shutting it down. Yeah, so now we have got that our comparative line plot, comparative bar plot. So I thought this should be, it should be a bar plot, not a line plot. Should be a bar plot, not a line plot, yeah. And we have got so many data sets. Call fossil. It doesn't look nice. By continent, I think I can remove here, yeah. X should be, X value should be continent, not here. Yes, this is what I want. So now for every country, for every continent, and this is gas, I can do biofuel, I can do coal, I can do fossil. Good. Now the next thing is now to combine all these four plots together into a final dashboard. So we have got this first one. Now this is the last one. So the first one was this line plot, which is going to be at the top left. The next one is, this one is going to be bottom left. And then the table is gonna be top right, and the bar plot is gonna be on the bottom left, bottom right. So now combine all the plots into a single dashboard. like that. Markdown, run it. For that I can say markdown final dashboard. Good. So this one I'm going to lift it directly from the website. So if you look at the HV plot or the panel website, it has got different templates for the dashboard. So there's different bootstrap, editable template, first grid template, first list template. So I'm gonna settle for this first list, and you can see generally how it looks like. So this is the template here. So in this case, we have got some radio buttons here, and then you can add some information here. So we're gonna write some information about this, and then have all our other plots here. So in our case, we're gonna have 4 of them. Here we only have got 2 ones that are comparing the sine and cosine wave functions. But in ours, we're gonna have got 4 plots. The line plot is gonna be at the top, and then the energy per capita on the bottom, and then the table at the top right, and then the last one at the bottom left, which is a comparative bar graph. So that is what we're gonna do. We're gonna copy exactly this layout here. So now to do that, the first thing is to specify the template we are using. So I'm gonna do template equal to pn.template dot first list template. That's the one I selected, so I decided to select first list template, this one. So we specify that template, and then the first thing that, so it generally follows the, if any one of you has been to website design, it follows that design. So the titles are based on how you name your titles or the output or the layout in website. So the bigger title will take the, it's like the markdown approach, the way I'm doing it here. If I want the title to be big, I'll use maybe just 1 hashtag. But if I want it to be small, I use the smaller, the many tabs I use, the many hashes I use, the smaller the title becomes. So in our case, we're gonna go that kind of hierarchical style. So the first thing is to write the title. And this, I'm gonna say continents use energy or electricity generation by continents. And then, so that is the title. The next thing is the sidebar. So this one is straightforward. Use the square brackets and then specify what you want to go inside the square bracket. So I'll use the panel function and then use pen. So I'm going to create the sidebar, kind of what you're seeing here. So pen, and then use the function markdown to specify that. And inside it, I'm going to have kind of the subtitle, which in this case, it's going to be bigger, but not bigger as the title. So just 1 hash, and then say electricity generation and emissions. That is that. And then the next title is gonna be pn.pen, again same functionality using the panel functions, but now I'm going to have a description. So this is going to be a full word. So I'm going to make it several. I'm going to give it's like the kind of descriptions we give here. In this case, like this. So I'm going to write some information here just to make the dashboard more interesting and appealing. So we can write something about the electricity generation. So we can just say, fossil fuels are one of the greatest contributions to pollution via carbon dioxide. The increased levels of carbon dioxide result. Feel free to write anything. Result in higher world temperature. Hence, global warming. Global warming alters weather patterns, leading to climate change. I don't know what I'm writing, but yeah, I think this is close to climate change. Since fossil fuels are used to generate electricity, it is vital to cut down their usage and switch to alternative electricity sources. Here represent the amount of electricity generated by different continents from 2000 to 2022. Yeah, I think this. We go to the next pen. So the next one, I want us to have a picture. So let me show you a picture that I downloaded on the internet that I want you to have it in your, just load it. So this is the picture that I got randomly from the internet. So this is what I want us to attach there. It's called energy.png. You should have it below the link. So please make sure you copy it inside the folder, your working folder, which in this case we've mentioned it or we named it to electricity. So I'm gonna copy it here. There we go. So I can say PN. Make sure it's in PNG. Whatever image you decide to use, convert it to PNG so that it becomes easier. PNG energy dot png. And then the sizing mode, remember different sizing mode we talked about. Sizing mode. So you want to scale it both by height and width. So I'm gonna just scale both so that it doesn't be overstretched or flattened. And then pn.pen .markdown. We're gonna have the radio button to slide around the ears, so we can call it settings. Then yes, slider. So I think this marks the end of the sidebar. So this is what is going to be everything that is going to be here. Now we have to concentrate on the plots, which are basically 4 plots. So that will go to main, and we use again the square brackets. So the first row, which is the top row, we're going to have the line comparative plot and then the table on this side. So let's define that row. pn.row. Same way you design your website. So pn.column. So it's going to have 2 columns. And the first column is going to have the y-axis electricity. Y-axis electricity. Let me just copy it. This one here. So it's going to have this. Copy. There we go. And then we're going to have the electricity plot. So I'm just copying them to make sure that you remember what you're doing. So we're going to copy this plot. So we take it, electricity plot. And then now we define the sizes of each of them. So the width stick to 700. Margin just go to 25. There we go. Then the next thing is electricity table. So that's what goes to the right side, which is electricity. I'm sure it's that one. Let me just confirm. Yeah, electricity table. So again, electricity table dot panel same width. We can use a smaller width because it's just 3 columns if I'm not wrong. So 500 will do. And then let's go to the last row, pn.row. So the second row has got the per capita and the bar plot, the comparative bar plot. So pn row, pn.column, make it capital, column, y-axis electricity. So this one is this here, so electricity. Y-axis electricity source. This line here, or the radio buttons. So let's do that. Electricity Y source. No. Let's start with the top one, the first one, which is kilowatt hour axis, yeah. And then same style, plain panel. No, we're using the plot, sorry. But we use the plot because that's what we're interested in. Okay, yeah, dot panel. And then specify the width. Width is equal to 700. And then comma margin 0.25. So that's for that. The next one is pn.column, the next column, which is for the comparative bar plot. And the first thing we do is to have the axis there we go, and then electricity bar, go for the bar, there we go. Dot panel, specify the width, same thing, let's make it a bit longer, and then closing bracket, and we need this comma here, and then we need to make the color of the top color of our dashboard, and then we also have got to the general theme. So I'll say accent, we use the accent, that is the top color, I mean the general color of the dashboard. So I'll use, you can feel free to use any color, I'll use just the default one given. So this is just the color code, so you can vary it the way you want. D8 B0, feel free to use any color here, you don't need to. This is where you can exercise your graphic designing skills. Background, D8BO. And the last thing that we want to do is to make this dashboard servable. In other words, you can deploy it on a server. So in our case, our server here is just my computer servable. So let's run this and see what we got. So that's it. Now the next step is now to deploy our dashboard. I'm not sure if mine is gonna work because I restarted it, but in your case it should work. So if it doesn't work, I will troubleshoot it so that you know how to go about it in case that happens to you. Otherwise, it should work at this stage. So to do that, it's very straightforward. Go back and launch the terminal. So click on this plus sign here, terminal, and then use the panel library to launch the server by just typing panel serve and then type the name of your notebook. So mine is elect.ipynb. So that should work in your case, and I hope in my case it also works. If it doesn't work, then I'll troubleshoot it here. Yes, so it doesn't work because I had restarted. So if that happens to you, then the best thing would be just close the Jupyter Lab, go back to your terminal. Okay, so I figured out the error. The reason why it wasn't working is I need to go back to my terminal, kill everything, so stop everything that is going on, and then once I've done that, make sure that I move to the folder. So let me just close this terminal and show you what you need to do if that happens to you. So open a new terminal, move to the directory where your code is. So mine is in the documents, and inside the documents, it's in the folder called your technical. And inside that folder, it's in the folder called electricity, the one we made before. And if you look at inside that folder, there's this file called bin. So you just need to activate the environment by typing source bin activate. Once you do that, you now need to launch Jupyter Lab. So type Jupyter Lab, launch it. It's gonna open a new Jupyter Lab where your code is. And now what I have here, can launch my notebook here, run it just to make sure that everything works perfectly before moving to the next step. So now to run the dashboard, same procedure, go to terminal, launch terminal, and then just type panel serve. The name of your notebook is elect.ipynb, and then run it. And then just click on this link, local co-host. It's going to open on a new page, and here you have your dashboard. So you can move, you start with 2011. So this is 2000. As you move forward, you can see the changes. So it allows you now to view the data set in different perspectives. So in the top part here is hydroelectricity, here is energy per capita. This is the table, and these are different fossil fuels. You can move that to 2020. And here you can change hydroelectricity to other renewable energy, and this is what you have. You can see it also changes on the table. You can do the same here, change biofuel to coal. See, North America and Asia is one of the leaders. Fossil fuels, still North America. Gas, North America is leading here. And the one good thing I love about this dashboard is you can even have, you can hover around the lines or even the plot to see the values. For example, if I hover around here, you can see this is Europe. The year is 2015. The total amount of other renewable energy electricity generated is 193 gigawatts. Same to this place. Same. So it's really nice. You can navigate through the table or through the table here to this page 1, page 2, page 3. You can rearrange them depending on how you want them to be sorted out. So this is a nutshell, and you can always change the dashboard depending on the theme. So these are the night theme, and this is what you are defining here. This is just a small image here to define what you are doing. So in general, I think the best way to visualize and analyze time series multivariable time series data set is to use dashboards, and you can also implement this in your kind of other data sets. So that marks the end of this video. I've posted all the relevant materials on the link below the video so that you can practice yourself. Feel free to generate other data sets or download other data sets from this website, and then you create a personal dashboard and share with me on the comment section. For now, bye bye.